So welcome everybody to the Keen Live discussion on education of IoT education. I'm Ayca Tuzmen. I'm here with my colleague Helen Chavez. Um, let's talk about the agenda for today's workshop or discussion. We want to introduce ourselves. We kind of did the introduction from you guys. So thanks for attending. And we want to talk about our objectives for conducting this workshop. And later on, we want to discuss and introduce you our framework, which is introduction of engineering design process with an entrepreneurial mindset. And we're gonna talk about some of our learnings from the execution of this framework. And we're gonna jump into the topic where we can discuss together the motivation and the evolution of the IoT education. So we look forward to your participation in this workshop. So really quickly about myself, I'm a lecturer at Arizona State University. I'm with the Fulton Schools of Engineering. We recently had a change in our school name. It's School of Computing and Augmented Intelligence now. We call it SKY. I have my PhD in design computing at ASU, and I have a master's in computer science again from ASU. I'm originally an architect as well. So I started dealing with sensors for architectural purposes way back. So we might have similar things in common, probably. Um, Helen?
Hi everyone. I'm Ayca. I'm a lecturer at ASU, same school. My PhD is in computer science, same with my master's, and my bachelor's in computer system engineering. And both my bachelor and my master's back in Mexico, and the PhD here at ASU.
We have a lot of audiences which has done some IoT or look forward to learn some IoT. That's really interesting. I'm just gonna go to our next slide, which is the workshop objectives. So like I said, we want to introduce the framework that we have been working on for a while. And we use this framework for teaching the first year engineering students. We follow the engineering design process, and we wanted to include the entrepreneurial mindset into this process. So the frameworks is designed for engineering students, introducing the engineering design process with an entrepreneurial mindset. And the objectives of this workshop is to share the outcomes and learnings that we have from the execution of this framework in diverse case studies. So we have a couple of case studies that we have executed this framework, and IoT technology is the new case study that we have been practicing with. And based upon these learnings, we want to introduce you, or we want us to discuss the evolution of IoT education and talk about our next steps. And maybe you guys can also introduce and share your next steps for the IoT education as well. Our framework.
Yes, our framework. So this is, as Ayca mentioned, this is a framework that we have been working with it for several years now. We have a group of colleagues that we belong to, and we have been working with this. And mainly, as Ayca mentioned, it includes like the engineering design process, and we included the entrepreneurial mindset. And basically, well, if we all might be familiar with the engineering design process, so we have all the different stages of it, and we included the EM parts of it, and we're trying to encourage our students and engage our students with those elements, as mainly to make them aware that whatever they are building, whatever they are creating, whatever they are developing, will have an impact in their society, community, or in a person at the end of the day. And that's something that it's interesting that the students are sometimes struggling with that particular part rather than with the technical part of it. But anyway, so we try to have them to go through all the phases, particularly in the requirements. We are trying to move forward and have them to get information from firsthand. So we try to bring people that could be part of the end users, so they can interview them, they can talk to them, they can get that information firsthand. We teach them a couple of different techniques and how they can do a better research. So we try to help them in some things that we do when we do research, such as previous work. We don't want to reinvent the wheel. We want them to build on the top of things that are already there. We want them to get familiar with the different technology that we will be using for the particular project, and we're going to talk about the different user case that we have. We go through the brainstorming processes again, helping them with some techniques such as design heuristics, decision tables, and we move forward. Normally, our implementation have hardware and software related. Again, we will explain that for each of the use cases that we want to share with you today. And finally, for the testing is both the technical part of it and also the user experience part of it. We are, again, also interested that our students can talk about not only the technical part of it, but also the added value and how that is going to improve the user experience in whatever area that we're trying to improve for them. So that's kind of pretty quick, the different phases that we have. You all might be familiar with that. So what we're trying to do with that is, or what we're trying to do is to formalize this framework and to use it in our regular basis. We have been using this again for, I don't know, maybe 10 years, 7 years, and we are trying to improve it. And we're going to share with you some of the evolution of this framework as well. But again, the main goal is for us to have students to consider different points of views and how to create value and how whatever they're doing has an impact, and how we can improve and work not only in the technical part of it, but in the user experience. So to give you an idea of the background of the students that we normally have, we have in the School of Computing and Augmented Intelligence, we have students from computer science, computer systems engineering, industrial engineers, engineering management students, informatics, and software engineering. So this is kind of the background of the students. So we're trying to get all of them engaged in different parts of the project, and our framework helps with that. So
hopefully our contribution is to the engineering education is that we have a formalized framework that can be used as a scaffolder to design, to implement and assess a new and holistic engineering based projects. And we are hoping that this will allow and enable students to consider diverse points of views. And they also consider the criteria to create a value. So there's a value to a customer, to a user, and they also understand and learn the impact. They observe the impact of technology and the human-computer interaction on the ultimate user experience. So let's talk about how we execute the framework. So like Helen was saying, this is the first year course for engineers, and the students we have are from computer science, informatics, computer engineering, computer systems engineering, industrial engineering, and engineering management students. And the case studies that we completed over the years, the first one is the SPIN project, which is the autonomous Lego car design for the transportation of individual in a wheelchair. This is a proof of concept project, but they are working on the design of this autonomous Lego car. The second case study we have is the fine motor skills project. This is a web-based and game-based application for improving the fine motor skills of toddlers or stroke patients. The third case study that we started practicing this and executing this framework, we call it Perceiving the World Through Technology project. And this is where we actually use the IoT technology, or the start of the IoT technology is actually, we have a microcontroller based system with sensors to support the vision impaired individuals. So a couple of details about the SPIN project. Like we said, it's mobility impaired person that we have, the customer that we have identified. The hardware that we use, Lego EV3, and we use MATLAB for the software. And this is a simulated situation. It's a proof of concept. A car needs to navigate through a maze and then be able to pick up the wheelchair and carry it to or transport it to a specific location. Robustness, steadiness, and safety are requirements for this project. The next one is the FMS project. It's for improving the fine motor skills. These are some of the examples we have from last year. Like I said, students can either choose to work with a toddler or a stroke patient. So they get to interview a sample of or a customer representing these kind of people that we have in mind. So students end up creating a web-based game application. These are some of the examples. If you realize there are a lot of tracing and a certain pattern or moving objects or typing. So similar kind of activities we have, we were able to implement for toddlers and stroke patients. The third one, where we are trying to use a hardware, which is a Raspberry Pi, and software we use the Python. This is specifically for vision impaired person. And we want to make sure that the technology that's being designed is interacting with the vision impaired person in a natural, regular, and transparent way. And we want to use it for real situation, for real problems. And the requirements we have is it has to be wearable, it's easy to move around, it's portable, and we also require it to be fashionable as well. So those are our requirements for this project. So if we compare them, you will see that we have different customers, and we are trying to make a value, create a value for a group of people who needs technology support. And we tried hardware and software technologies. The second one is mostly software, but we got to try hardware and software together. And the skill set that we are trying to target, first of all, assembly of the hardware in 2 of our projects. 3 of them has the software programming skill set requirement with different languages. And with the FMS, we have the user experience and the UI design skill sets that we wanted to bring in, and also allow the students to think about gaming and then consider the gaming requirements. And the third one, additionally, on top of the UX and UI design, we wanted to embed the system as well. So that's the kind of skill set which seems to be growing, hopefully. And the outcomes, the second 2 of them are just prototypes. The first one is just a proof of concept. So if you could see the difference between them, this is shown in this table. Any questions so far? I'm just curious. I'm gonna look into chat. Helen, do we have any questions that we want to target? No? Okay.
Not yet.
Okay. So let's ask you guys. Let's have you think and share some of your thought with us. So we're just wondering what kind of other case studies out there And if you could share with us, what kind of case studies did you conduct before for teaching engineering students the engineering design process? If you could think about it and share your experience, you can either talk to us or write it back to the discussion in the chat area.
So this is Daryl. My context is actually significantly different in the sense that I'm in charge of our capstone courses. And so our capstones take students through a project that is sponsored by an industrial partner typically, which provides a lot of very useful real world grounding for the project. It also quite often provides significant challenges because the students have an industrial partner that's telling them what to do. And quite often the industrial partner says, I know the solution, you don't worry about that. Just do what I tell you, as opposed to trying to understand their audience and trying to understand their customers and so on.
Okay, thank you.
Hey, Larry. Jim mentioned in the chat that this doesn't apply to him directly because he did not teach first-year students during their full time. But I don't know, Jim, if as Daryl shared, he works more with senior students. But if you have any experiences on this, we would like to hear.
So I did do some capstone projects when I was at in the engineering department for electrical and computer engineering. And we did not have industrial sponsors lined up for the majority of our senior capstones. Most of them were self-developed with a faculty advisor, and sometimes the ideas came from the advisor, sometimes the ideas came from the students. So by the time, and then I was an advisor role. I had an advisor role probably for maybe 5 or 6 years when I was, doing this. And, I was gravitating towards security-minded projects and IoT-minded projects. And to some degree, I was, somewhat successful. But I had the students, as rising seniors. So they were spring semester juniors where they designed something, and then fall semester seniors when they implemented something. And so, this... And Keen was only a minor, the entrepreneurial mindset was only a minor aspect of that whole experience. I think it was underrepresented actually in the way Villanova did its business, because it was a strong Keen partner in its early days. So I don't know exactly how they lost their way, but they did.
Jody says she has case studies regarding games for kids. It's similar to our toddler games, probably. Thanks, Jody. And Anne has a question. Do all these 3 case studies take the same time? Yes, they do. They are given approximately 10 weeks. It's not the whole semester. We have another small project. We use a similar framework, but the actual framework is implemented in the 10-week project, and they all take the same amount.
And just to clarify, each instructor have kind of the decision, or we can offer the projects to the students, and they kind of decide which one they want to follow. So it's not that every single student go through the 3 different projects. They choose one and they work on that for the semester. And if you can go back to the table, Ayca, really quick, I just want to point to something. Yes. So one of the things that we have, as Ayca mentioned, each project, so it has a different components, particularly in the skill sets. And that also has an impact in the framework that we're trying to define. So to give you an idea, that the Spring project, we use that, the Lego one, we use that for maybe 5 years. And then after that, we introduced the second one, the Fine Motor Skill project. So we started with that in August 2020. And we start like introducing like new things to that project in the skill set about UX, UI, and gaming. And that the impact that has in the framework that we're trying to define is in the milestones that we define for the project, right? Like, okay, it's not only about the technical part of it, but we also care about the UX and the UI. And when we move to the third project that we introduced, this one last fall in August 2021, we also added the embedded system design, the IoT things that we are trying to move forward towards that. So again, this is kind of a evolution of projects, but at the same time, an evolution for the framework, and that we're trying to, as we said, formalize the framework and prove that it worked for different kind of projects. But that's how we can, just to share kind of the evolution of the projects and the evolution of the framework.
Thank you, Helen. So thank you guys for sharing your experiences with the case studies you have. So now we would just want to go into the stages in the framework and talk about some of the stages in the framework and what could be our requirements. So Helen, I'm going to let you.
So as we mentioned before, we follow the engineering design as the base for this framework. So we want to talk, or we want to talk about, okay, what we did for the third project. That is the one that is related with the discussion that is about IoT. So again, for the requirements gathering, we try to improve the experience for the students, and we invite people in the population. We invite vision impaired people to come to the classrooms and talk to the students and share their personal experience. And again, with the final goal of for the students to be aware about the impact that whatever they are doing will have, and to get information firsthand. And that being, regardless the information that they get, and that is better to get that from the final user. The whole experience of having the person there in the room and having access to them, we notice that has been a difference. So in this phase, again, we emphasize on the requirements about functionality, the two things that we mentioned, wearability, portability, and then the fashion. And again, fashion, the part of the fashion is when the students start like struggling, like, okay, we have the technical part of it, now how we solve the fashion part of it. So when we talk about the research part, so we focus, okay, what are the solutions that are already in place? So the person that the person who interviewed with them normally mentioned, okay, there are solutions out there. One of the main problems is that those solutions has like a very high cost, they have limitations, but there are some stuff, and for some stuff, some experiences or some problems in their daily life, their answer is normally you have to deal with that. So part of our purpose is, okay, how we can help them, not to be them to the ones adapting to the environment, but the other way around. So again, this has been open a door to have really good discussions with the students about, again, the added value that whatever they are creating, and also not to reinvent the wheel. So we ask them, okay, go ahead, find whatever is out there, and review that. So if we, about the next step, that is brainstorming. So again, we guide them to have brainstorming sessions. We talk to them about design heuristics. If you're not familiar with this, it's a technique that you provide some cards that serves as guidance, as okay, to think out of the box kind of thing, so they can get inspired on how to reuse a title idea and get better. We ask them to provide us with the sketches. We ask them to assess their solutions using decision tables, and emphasize on the importance of the requirements and the good, how important is that when you define your requirements, they are good and they are well defined, so you can use them to assess your ideas. So we have a couple of examples in the next slides about, okay, what they did. So they start thinking about solutions. Some ideas here is they think about, okay, they might need help having a sensor to recognize the color of the clothes that they want to use, so they have better combinations. They decide, or another idea is how they can add some sensors to a shoe, so when they navigate through open spaces, they have a better idea of obstacles that they can find. And this is inspired in the fact that the person shares that they use a cane, so they have one hand already occupied and they only have one hand free to do other stuff. So they were trying how to help in that. They thought about, okay, temperature sensors that they can use in a bracelet kind of thing. They also have sketches for glasses with different sensors that help them to identify, again, obstacles in a room, in a path. That is inspired by the fact that the person mentioned that with the cane, they are covered from the waist down, but when they talk about, okay, how they bump with open cabinets, open doors from the waist up. So they decide to, or they design these glasses with sensors and different type of feedback to let them know, okay, where there might be an obstacle. So these are some of the ideas and some of the sketches that they create in this stage. Moving forward, about the implementation, yes. So again, we use the Raspberry Pi, we use sensors, that is where the IoT starts coming to play. And we provide them with some introductory classes about Python and about how to work with the sensors with Raspberry and how to program them. We have them to go through process of system configuration, so they have to deal with that. And then they just play with Python and combine sensors. So for this particular project, we asked them to have these two different sensors collecting data, and then at least two different type of feedback to the user. So they need to play with these 4 things. And then the end of the day is for them to create prototypes. So here are some examples of what they did. The one in the left is a hat where they created, or they created a 360 coverage. So you have 4 sensors kind of thing. So you can put the hat, walk around, and then it will tells you if there's an obstacle, a wall or something, or cabinet. And then the feedback that they used was a buzzer, or with a motor vibrator, so you can feel it in the different part of your head. Another team made, they call it a cup buddy. That is the sensor that you can put in the rim of your cup, and then it will tell you when the cup is getting full, and also if the liquid that you're pouring is too hot to be drinkable. And then a third example is a color sensor speaker, that glove, so people can wear it. And then it has the sensors to say, okay, this is what kind of color for your garment. And it also lets the user know if you are too far to identify the color, or too close to identify the color, or is not enough light to identify the color. So it has a light if the sensor detects that is not too much illumination. So these are kind of the final products that they created, and all the data that we collect with these sensors, and all the different type of feedback that they provide. So this is a very quick, just to show you what we're doing. And then the next step will be move forward to work more with communication and IoT component. But before that, we want to also discuss that we also have the testing part of it, and we have them we have the students to do that user experience study, where we have different, last semester we were not able to invite blind people to test the products or the prototypes. So we have them to test it among themselves. But the idea is that to have them like actually experience the prototypes. And that was also a good experience for them. We did that twice in the semester to provide like early feedback, and then at the very end. And again, it was a good, for them was good to see, okay, this is what it means to have a product center, customer center. So we get early feedback, we can do adjustments, and that was also a good experience for them. And again, this is kind of the framework, the different stages that we followed. Each of those stages has a milestone or a deliverable related to it. So the idea is that we help them students to keep on track, to be aware of what are the things that they need to focus on to make able to complete the project in 10 weeks. And then now we have another question for you. So, well, I just speak.
Sorry, fast.
So now the question is, what are some case studies that you can think or that you can consider that we can use IoT technology for teaching engineering design process? And let me share you what is our idea. So as I mentioned, right now we have the students working with individual projects, and we are aware that we collect a lot of data that can be very useful. And our next step will be to how we can start like sharing information from different products, right? So we are imagining, okay, this team has this particular product with this set of sensors, this set of feedback. And what we're trying to do is, okay, start having those things talking and reacting and adjusting. So that's kind of our next step, and we're going to discuss that later, and Ayca is going to go further on that. But we would like to hear what other kind of studies you can think that we can use for Internet of Things to teach our students.
Well, the one thing that I would suggest is that IoT needs to be an edge to cloud experience. So that you have the sensors on the edge, and then those can have actuators associated with them. And that's fun little toys to play around with. But then in the end, it's about the data reaching a point where it's collected and analyzed, and then it has real-time impacts. So a case study that maybe somehow uses Amazon Web Services to realize the cloud transfer and that kind of thing. So, you know, where that's appropriate in the curriculum, I don't know, but it's the kind of thing that I've, you know, seen used in the capstone kinds of projects where you know, it's more than just the pie and a sensor, which is kind of what you do in these for freshman courses. It has to be something where it starts there maybe, but then it goes much beyond that in terms of data aggregation, data transmission, data analysis, and then, you know, having multiple layers of UI, for example. So you'd have a cloud UI and a Raspberry Pi UI, or maybe even a little LCD, you know, on a panel that's on somebody's wall, you know, UI. So all of those things kind of organized together would be case studies that I think people would benefit from learning about.
Thank you, Jim. Actually, we're going to talk about it in our next slides, but thank you for bringing that up. So far, we are at the early stages of the IoT education, so definitely we need to have those pieces in there as well. Thank you.
And Anne has shared that for her, some cases have started with known engineering failures, and that's pretty good idea. And talking to the students about, okay, we tried this, it fails. So what can we learn from that experience and how we can use that knowledge? Yeah, thank you for sharing that idea. And
also may add, I've been teaching IoT for a few semesters now, once a year actually. What I also add to this is I teach them a little bit of RF planning as well, to the extent that they can, if they're designing a system, I mean, an important factor in IoT is power usage. And longevity of the sensors. So you can set up a system where everything works according to plan, but the sensors are typically wireless. No, they have wireless connection to some access point. And if they're not RF planned correctly, they're going to transmit more power than needed. So I show actually to students that you could be off by a factor of even 10, 20 times the power that you need. Now everything will be working, except that instead of the battery lasting you 5 years, it's going to run out in, let's say, 6 months instead. So having a good RF plan when you deploy a system, I think is crucial.
Yes, that's for sure. Thank you for sharing.
You have one case study which is really interesting that Daryl has shared. It's about device to filter rain runoff water. That's an interesting case study. Daryl, do you want to talk about it? And it looks like there's an industrial partner.
Yeah, we have an industrial partner that builds devices that filter runoff water. So this is an environmental engineering problem essentially, but they want to do things like monitor the condition of the filter, monitor how full the filter is of dirt and debris and other things like that. And so they're asking our capstone team to put together sensors as well as the required communication infrastructure to monitor these remote filters.
That's a good
Thank you,
idea.
guys.
And commenting on what was about the scope of the class. So yeah, we need to be aware of that, right? So this is again, this is mostly focused for first-year students. So most of the time they are not familiar with anything related to coding. They might have an idea because they have had a class for programming. So the goal of the class is not for them to learn how to code, and we have another class for that particular goal. Normally they took the class at the same semester, but we kind of provide support for them about that, right? So they can actually learn something, they can actually perform good in their project. But the focus for the goal of the project is not coding, is more about, okay, learning techniques, learning processes, learning how to create a good solution and think about the added value. But yeah, that's a good point that we need to be aware of that. Okay.
I'm going to move on to our motivation for education for IoT. That's we already know that there is a demand for and there's a need for IoT education. The research shows that as well. This is one report from Microsoft regarding the IoT signals report. So I'm not going to go over this, but there's a need for IoT education, definitely. And companies are also investing, and over time, you have seen that they are also investing in the intelligent connected devices. Again, this is another motivation for the education of IoT. But let's just talk about what we think should happen for evolving in this direction. Like Jim was also mentioning, for now, our project, it's the first semester, we were able to digitize, create a digital copy of the environment. So we were able to transport the analog data into some kind of a digital copy. We were able to collect within the same device some data, analyze it, and use that data to respond back to the same digital copy. These are the ones that these two steps were the steps we were able to conclude. But for the evolution of the IoT education, we definitely need to be able to store that digital data on the cloud side, so network it. And on the cloud side, we need to digitize it, make sure that we have the analysis of that data and make a decision out of it through the analysis. So that's the intelligent piece that needs to happen. And hopefully with that decision making, we can maybe connect to a digital copy again, or a totally a different digital copy out there. So we want to distribute that intelligence, and hopefully we achieve the intelligent connected devices through the evolution of this IoT education. So we are at the early stages of this evolution. We were able to create a digital copy collected, but from now on, our next steps is to network it, make it more intelligent, and hopefully distribute that intelligence among more than one thing. So it becomes Internet of Things. So at this point, Helen, do you want to add anything to this?
So, and again, yes, and so the main motivation is, of course, to make aware the students of the power of the things that we can do. And at the beginning of the projects, they also say, like, are we actually doing this project, or is just going to be a mock-up? Like, no, we're actually doing it. We are going to be working with an embedded system and the sensors and all this kind of stuff. So they're a little bit skeptic and a little bit concerned about it. And anyway, so they get engaged working with that. And moving forward in this cycle about the IoT is like, we consider that will help a lot for them to really understand how whatever they can do and all the data that we're collecting, it can have an impact in how some decisions can be made. With whatever device that we are doing or whatever solution that we're working on. So, and again, we're trying to emphasize on the fact that we want the students to be aware of the impact and how they can shape the way things happen. So, yep. So
our challenge here is the time as well. We have 10 weeks to do all this stuff. So we were hardly able to complete the 2 stages in 10 weeks. So that's a challenge for us as well. I think the framework will be able to support all these phases with an iterative fashion. As long as we follow the same framework, I think we will be able to go through these phases. The framework is designed for that. So next is, I just wanted to get your thinking happening and then your sharing with us. I'm just curious, what other approaches would you recommend for education of IoT? Some of you already mentioned this, like having cloud connection, but on top of the plan we had, do you guys want to add any recommendations, any approaches?
One question that I have, which has been pretty consistent in all of the courses that we've done that have used any computing at all, is how do you teach an IoT class to students who have limited programming abilities and experience, and some of whom will actively resist gaining any experience in programming?
That's a really good question. So what we have been doing, and this goes for the 3 different projects that we share with you, is we provide them, or we create a set of tutorials and a set of material. And again, the goal of the class is not for us to teach them programming. So we are okay to providing this kind of help and this kind of tutorials and this kind of material. For instance, when we work with the Legos, we provide them with a lot of libraries and a lot of things that the team created to have them or to help them. So programming is very, very straightforward. When we work with the second project about fine motor skills, we use a platform, the P5 JavaScript. And again, we create a set of tutorials for them. The P5 JavaScript has a lot of resources in their own website. They have a lot of videos, a lot of examples. And again, we are okay with them checking all that and use as long as it's legal and not breaking any rules about intellectual property or copyrights, for them to look and not to copy 100% of the code, but it's like use that as an inspiration. So we find that the students are good with that. They can do that. For the IoT things, the first thing that we do is first showing them, okay, this is Python, it's a different programming language. We have a class with them about really quick, it's two sessions about structural program, conditional statements, loops, if, for. So give them an idea, kind of so for them to be aware. And then we have a session or two sessions where they we provide and we create a tutorial, again based in resources that we have online for them to interact with the sensors. And I wouldn't say that 100% of the students get engaged, but a good percentage, 90% of the students, 95% of the students, they get really engaged. They are playing with the sensors. You can see them like connecting and doing all that. Of course, we cannot expect like super correctness and robustness on all the applications they are doing, but it's a first step moving forward. So that's at least that has been my experience.
So really quickly, yes, we do provide a lot of templates and examples that they can reuse, and they can also require to go out there and do their own research. So a lot of the learning happens on their own time. We just point them to the right locations, and then they learn how to learn. So really quickly, I just want to wrap up with the final thoughts. I'm gonna, Helen, let you go over this and add to it if I need to.
Yes. So what we're trying to share or to do is not to share. What we're trying to do in our next steps is continuing improving on the framework that we have in place. Try to review the different entrepreneurial mindsets, measurements that we have in each of the stages to make sure that we are helping the students to get this mindset. We want to emphasize about the added value and the impact that the solutions that our students create will have in final users. This is something that we notice that we need to improve in our programs. And also, we are aware that we should include integration, like as moving forward in the IoT education is about, okay, we need to be aware of that we need to add intelligently connected solutions and the network solutions, as was mentioned, the cloud concept and usage. We need to move towards that direction. So, and Ayca, if you want to compliment.
So, I have been teaching IoT for a couple of years, and actually getting onto cloud, connecting things on the cloud seems to be getting much more easy now. It's just a matter of going through wizards. AWS is one of them. It makes it so easy to connect an IoT. So technology is also helping us teach the education of IoT as well. So connecting to cloud hopefully will be achieved faster, and then making decisions and then tying the different objects to each other. I think we still need to make it much more easy for students actually. If the students need to do this, they should be easily be able to go through some wizards and then make the connection between different things easier. So we definitely need to decide on a platform that will help us educate these faster. Well, actually, once they get the hang of it, they should be able to get that same learning and apply it to different platforms. Same learning. It's just a matter of making sure that the object they digitize is able to get onto the network and talk to some of the decision-making systems, and then be able to connect back to the device again. So they just need to understand that process and be able to implement it. So I just want to thank you guys all for attending this workshop and sharing your experiences and your recommendation with us. I just want to make sure that we are still connected in some way through this evolution. Hopefully there will be more workshops like this from you or from us.
And if you move to the next slide, there is our emails. If you want to connect with us at any time, we will be more than happy to have you. If you want to, we can invite you to see demos of the things that we're doing if you're interested in that. So you can see the presentations and you can see the projects. We will be more than happy to do that if you're interested.